Right, we're on with another project here, and myself and Lee have been thinking about building small system voltage batteries based on the old 18650 lithium ion cells, or the 20 by 70 cells, with slightly bigger. Anyway, these ones are 2 amp hour, the slightly bigger ones are either 3 or 4 amp hour, but I happen to have quite a few of the 18650s. So let's just dive down onto the workbench and see what's going on. Right, this here is a piece of overflow pipe from domestic header tank, the water header tank in the loft. This is the overflow pipe, 20 mil, and I've just slit it down the middle there with a 4.5 inch angle grinder and one of those 1 mil discs, and it slit very easily. So now I'm going to cut this into short lengths to make those, right? And the reason for those is that when I'm building these, here are bundles of 4 cells in parallel. So you've got 4 in parallel, in series with 4 in parallel. So we've got 8 amp hours there. So it's a matter of, on a 48 volt DC system battery bank, you either need 13 or 14 of these in series. So it's called a, for instance, on 13 it will be a 13S. So I've got various cells here that came out of electric bike batteries, where some of the cells had gone duff and where the BMS had gone duff and whatnot. So I've harvested some of those, and I'm just going to go through the various options that I've got and show you what's going on. But first of all, I'm just going to cut these up into short lengths, like, I don't know, 10 or 12 mil on the bandsaw, and I'll get back to you. Okay, that was successfully done. And just get rid of the hairy bits like that. Now, where are we? Let's try this. So there we go, we got an 18650, 18 mil in diameter, and that will just push on like that. Marvellous. Wherever the split is, work from there. Okay. The main thing here is I don't want to just tape 4 of these together so the cases are touching. I want them to be like that, so there's an air gap. Let's just zoom down a bit. So there's an air gap between them. Yeah, okay. That way they're well ventilated. So what I propose to do, both negatives on the end, yeah, put the slot, we need those to be organised so they're on the same side, like that, and I'll put those together and I'll just daub a little bit of hot glue in there. I lost you there. So I'll put these together and then I'll just put a little bit of hot glue there, and then build the other one, and then we got 4 that can be wired in parallel to make it up one unit of a nominal 3.8 volts at 8 amp hours. Okay, so we've got that there. So the hot glue has been on for a while. There we go. Just put a bit of hot glue there and let that cool. This other one, gaps to the outside, like that. Negatives on the bottom, or negatives at the same end. A little bit of hot glue there. A little bit of hot glue there. Okay. Let those cool a minute. And then that one goes on there. So we put those two together like that, and that hot glue is just cooling off, and we turn it upside down, and then a little bit there, just a little bit, there we go. And I'm happy with that. That's clamping those, but we've got ventilation. Yeah. I think it's important that all this is sort of ventilated, so that you know, any charging heat does disappear or dissipate, rather than building up in a core where they're all sort of taped together or something like that. So there we go, and they're all adjustable in those little housings. That's it, that's good. Now let's just zoom out a bit. What we have here, I'll take this one here. This came out of a electric bike battery, and there were some of these units where the cells were totally duff. Where's the voltmeter? So where are we on this one? Yeah, 3.6. Okay, so some of them were duff, but rather than waste these nice cases, I removed all the connections. Where are we? See, the connections on the end. So I got the screwdriver under there and peeled those off, so that then these two halves came apart. Yep. And I was able to repopulate them with better cells, with tested cells. So now I can put some nickel strip across there, and we're back to normal. So we want 13 of these. Yeah, so we have to build it up, which is why I'm building these up like this. Yeah. So once we've got 13, I can start putting things together. I do have a BMS, a 13S BMS, and that will be quite fiddly to wire up, because there'll be a wire to every junction, as well as a positive and a negative. Yeah, and this battery, let me just move this out of the way. This battery is going to be quite long, but because it's experimental, I'm more than happy with that. Where are we? There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We want one more. Yeah, so we got some here. I shall use some more of these, build up another one, and then we got 13, and we'll need to have positive, negative, positive, negative, positive, negative, etc, etc, just so that we can series all this lot up. Interestingly, this pack here, although it was an experiment, but this white plastic here came from within a Dyson battery pack, and I was able to cut it up, and that's not bad, is it? there's a bit of ventilation there, but I prefer this idea. So I'm going to take this apart and do these. So I'll leave me with that, and I'll get back to you shortly. Oh yeah, this is what I mean. This is out of a Dyson, and you see this white here. So I removed the cells, removed the BMS, cut all the interconnectors off, all these connections here, and under here between 4 and 5 there's a heat sensor, and you've got to chop that heat sensor off and remove it before either of these two cells can be removed, but the other ones slide out quite easily. But this white thing here, when the cells are gone, I cut down there, and then can't remember, down there and down there, and those give you those two cell housings, what have you. But as I say, I prefer this. Yeah, so let's crack on. Right, well, this is a Bosch electric bike battery. Yeah, that's the case, and this is what remains from the internals. Again, those four are all in parallel, and then they're in series with those four, and then in series with those four. So it's the same sort of format, but these are LG cells in here. Right, how are we going to do this? Yeah, that's alright. So I've put these on trickle charge. I charged this pack up and then left it for, I don't know, a couple of months, and it was virtually flat, which does not bode well. But I was maybe thinking, because the whole pack was flat, I was maybe thinking there was a problem with the BMS. See, this has been trickle charging for 2 or 3 hours now, yeah, and that has gone down to 0.3. So that pack is duff. That is 2.7, so that's promising. Yeah, right, let's go over to there and there. That's 3. That's alright. This one, 2.5, not too bad. This one here, 0.1. Yeah, and then it's these ones on the end, which is 0. So within that pack, even within that half pack, we've got some half decent cells maybe, and we've got some duff ones. So I really need to strip those out and send the faulty ones off to recycling. And it literally is a matter of just peeling these connectors off, this nickel strip. Bearing in mind, on the positive you've got to be careful not to short out against the negative. There we go. So there we go, really sharp points there, but that's 4 positives there. And then let's turn it over. I had a little screwdriver somewhere. There it is. And we need to get underneath there somehow. Negatives a lot easier to remove. So let's just bend that round like that. There we go. Now on these there's some little black tabs that you have to cut off, and they hold the batteries in place. Right, hopefully they'll push out now. Yeah, there we go. So we know that one is from a duff lot, so that can go straight for the recycling. But you got the idea. I'll pick out the good ones, the rest can go. There's no point keeping them. And you think, oh well, you can charge them up, but if I was trickle charging for 2 or 3 hours and they were showing 1 volt, and then within 10 minutes or half an hour or whatever it is they've gone down to nothing, then they're scrap. Yeah, so there you go. Bike batteries, yeah, commonly 2 amp hour unless they're the bigger cell. Worth harvesting, as is the cells in Dyson units or VACs, or domestic vacuum cleaner batteries, are the slightly bigger size, and they're either 3 or 4 amp hour. Right, let's moving on. That's a bit more information spread about. I'm going to finish taking this apart before I start thinking about that. Now then, I've got some of these packs together. They're like this. Okay, and I found that the majority of the LG cells out of that Bosch bike battery were self-discharging, which was quite disappointing. Let me just see what this says. Yeah, it says 2.9, and I did charge it up to 4. So that's 3.5, and that was charged up higher. So that was rather disappointing. Anyway, I've got all these charged up to 4 volts. Yeah, all of them. And I'm just thinking that if I do that, that's quite a long battery. Best part of nearly 2 foot long. But I could do that. But I would have to put it on a baseboard and have a little something down the middle to divide them, and a bit of something on the outside. So I've got to think about that. But what we need to do and make sure that we know what's going on is we go between there, and that end is the positive. So that is a plus, and this end is a minus. And on the other one, I didn't show you that, did I? So is that the positive and that? No. So therefore that's a negative and that's a positive. Okay, so there's a join there, so 24. Okay, so that is the positive, and this end, which is there, is the negative, and they're all at 4 volts. So that would have to go that way round if I did it this way, and then we would connect from there to there. Yeah, so we'd turn that the other way up and put that as a positive. So we could go between there and there. Now I'm thinking we could probably put a fuse in there halfway along the pack. I don't know, a 15 amp fuse or a 20 amp fuse or something like that, just in case of unfortunate things. But I don't think we're going to get anything like that, because this will be in parallel with other packs, so it will probably only be charging it up to 10 amps, something like that. Yeah, but probably less. Yeah, so that's that plan, and I've yet to work out what's going on. But here, now this is a 13S. I'm wondering if you can see that. It's a 13S BMS. Okay, and I've got the, luckily I fitted this to something but never actually used it, so I removed it, and that's why some of these wires are a little bit short. Okay, which is, I'll have to work on that, but I do have the wiring diagram. Okay, so the positive is straight through, and is that the right way up? Yes, it is. So the positive here is straight through, and everything is switched around the negative. Okay, so when we look at this, I'll tell you what, let's put this down here and move the camera. That's a bit better. So the first negative is connected to the black there. That black is connected to the negative. Great. Okay, same as that. That one goes up to there. So that's the negative. And that is the negative also. Okay, so effectively that is the negative charge or discharge. Yeah. And then each one of these wires, see that yellow one there, that yellow one there, goes between battery number 1 and battery number 2. So on this, that's the negative, so the yellow wire goes on that link there between 1 and 2. It's not rocket science. You just got to make sure that the right wires go in the right place. We've got all the batteries wired together. I ran out of nickel strip whilst I was doing these batteries, so I substituted it with, sorry about that, this is the wire out of mains 15 amp 2.5 flat grey cable, and it's just soldered on. But you've got to use a bit of a rip snorter of a soldering iron with plenty of heat, so you can put the heat in rapidly, and that's the one I used. That's the scale. Yeah. So I'm going to put this together without filming it because I need to concentrate on what I'm doing. The only thing that I am musing upon as well is if I want to add any more cells to this in parallel, do I want to use the same BMS, or would I build another pack and have a separate BMS? Now these batteries here are 2170s, not 18650s, and they're 3 amp hour each, and they're slightly bigger. Now I've got some of these. The whole thing is, you know, really these cheap BMSs, how good are they? Yeah, how good are they at maintaining the balanced charging, and also preventing overvolts. In this situation where we're going to be putting this in parallel with lead acid, the overvolts is pretty important. So when I'm testing this, I actually probably want this in a container outside the battery shed, just in case, because this is lithium ion, not lithium iron phosphate. So the lithium iron phosphate are a lot more stable and they run at a lower voltage per cell. So these are the ones that, you know, if you get something mighty wrong, they get mighty warm. But I can't see that they're going to get mighty warm because we're in parallel with other things. So we're not going to be putting huge currents through these things. So let me crack on with this and I'll get back to you when I've wired it up. Right, where's the drawing? We've got this sorted out. There's the negative as per there. Okay, and then from the negative there goes to the negative of the battery. Then all the balance charging wires are connected, and then I've got this meter here across the positive there and across the negative there, so that's strictly across the battery, nothing to do with the BMS. Okay, so interesting. And can we see that? We can see that. So between the positive, which is there, and the negative, which is there, we have got 50 volts, and across the battery we've got 52. So 2 volts. But anyway, let's see what happens. We have a fuse. We can probably see it down there. It's a 10 amp. There it is. Standard automotive fuse. Just in case, and it's in the middle of the pack. For no other reason than if there's a fault on one bit, then if there's a short here, then that'll blow and it won't affect that, or it was the easiest place to fit it, etc, etc. Right, the only thing to do now is to connect it to the battery pack in parallel with the battery pack and see what happens. I assume the onboard voltmeter will go up. I'm not quite sure whether I ought to put a resistance in line. They're fairly well charged, these, because I've charged them all up on the bench power supply and made sure they're all 4 volts. So I don't think we're going to get a huge inrush. There's only one way to find out, isn't there? Right, let's do it. Okay, we're set up, and here is a link to the main battery pack. Yeah, so we're on DC 200, yeah, and what do we got here? Across there, and there is 47.7, and then across the battery pack itself we got 56. So put the fuse in and stand well back. Alright, no big sparks. Okay, and the voltmeter's going up. I wonder if you can see it. Yeah, there we go, 51.9. So let's just go across one of these packs here. 4.1, 4.1. The battery itself 52.8, so we have a difference with the meter. Yeah. .8, that says 51.8. Well, that's about typical, isn't it? But never mind. Let's try a different multimeter. Back in a second. Okay. There's a different one. So we're across the battery pack. 52.7. So that is not very accurate. That says 51.8. Okay, and what does this one say? Just as a matter of reference. .8, yes. So the voltage is going up according to the multimeters. Great. So the batteries are charging up, but it's not a huge inrush, which is superb. Okay, I had this on test for a number of days connected to the big battery pack, and it was charging fine. By the way, I changed this meter. Let me just for a 3-wire one. There, where you have a negative and a positive and also a power feed. So that's correct. So as I was saying, it was charging, but it didn't seem to be discharging. Now, I've had a look on eBay. This was bought from eBay probably at least 3 if not 4 years ago. Yeah. And I've had a look on eBay now, and eBay's full of them with all the same documents, and it's a total how can one put this? I'd say it was incorrect. So what we have here is the first document. Can we see that all right? Let's just zoom down on it. There we go. It shows charging, discharging. Okay. Right. On this one, it shows charging and discharging. And the other weird thing is here, from nowhere at all, it shows a link to positive. Which is odd, because the last one of the balanced charging wires should go there. Whether or not that is just, well, it's incorrect. Well, both of them seem to be incorrect. Anyway, let's zoom out again. So we've got the fuse in place, and we've got the amp meter, the voltmeter in place. And what I have here is and I don't know whether you're about to see this. Where are we? Turn it around. 40 volt, 40 watt, 50 volt bulb. Okay. So where are we? We come round the other side, so I'm not leaning over. Yeah. So we've got one in there, one in there, Okay, so that's direct off the battery. And now from the battery to, this is theoretically the output. Nothing, absolutely nothing. There's the output also, and on the one that they say is the output, absolutely nothing. So this hasn't been, well, it has been used, as in I've been testing it for 2 days, but I suspect it was faulty when it was sold to me, but I haven't got any recompense because it's so long ago. Now the question is eBay full of electronics equipment from the other side of the world that's faulty anyway, and it's based on the fact that it's too much hassle to send it back? Yeah, so they're getting rid of their junk by trying to sell it on eBay. It happened, the same happened when I had that speed controller, when I was doing some experiments with the electric bike. Yeah, and again another one, same happened when I bought a BMS for the Yamaha electric bike. Charge, wouldn't discharge. Yeah, and the thing is, where are we? Down here, underneath this heatsink, there is another connection there, though makes no sense to have it, but I did put a wire on it and brought it over to the positive as a final resort to see if we could get everything. And again, no, that would be positive anyway, right there. Yeah, but no, we're not getting any joy. So I've been sold a duff one. I think loads and loads of people are sold duff ones, so we just shouldn't be buying them. But the warning is that these BMS, the 24 volt and the 48, this is a 13S, which is 48 volt, there's a good chance they'll be duff. So rather peeved about that, but then what do you expect? They're dumping junk on the market. Right, with that, comments please. Interesting sort of experiment so far. To get a 13S lithium ion BMS, you're talking about maybe 50-80 pounds, that sort of thing, or so it seems. If anybody can find any other ones of a decent quality, the ones that you see on eBay, they're Daly or something like that, DALY. Yeah, they're all over the place and they're more expensive, but they're made in the same place, Far Eastern distant lands. Okay, catch up with you soon. Cheers for now.